Hey guys, hope you guys are having a great weekend. We're looking at using logs to solve exponential equations. So let's take a look at number one. First thing, if we're trying to solve this equation for x, remember the goal here is to isolate x. What does x equal? So generally speaking, we're trying to figure out is 3 to what power will give us 30. Well, we know 3 to the third power is 27, okay? And so it's going to be a little bit more than 3. 3 to the fourth power is 81. So we know it's going to be like 3.1 approximately. So I'm going to do an approximate here of 3.1. Let's see what it actually is. Now, one of the things you can't do here is you cannot divide by 3 because this is a base and it's raised to an exponent, okay? So you cannot divide by 3 on this. So the way you want to handle this is we're going to use logs to solve this, okay? So first thing we're going to do is we're going to take the log of both sides. So we're going to have the log of 3 to the x equals the log of 30, okay? And then we're going to use our power property, and remember when you have an exponent on the base, that can come down front. It can also go back up on top, but in this case we want to bring it down on front, in the front. So we'd have x times the log of 3 equals the log of 30. And what's nice about this is that when we put the log on both sides, the base is 10. We're using a common logarithm to solve this, so nothing fancy here. We're just using base 10, so we can use our calculator. Alright, so since we're having multiplying here and we want to solve for x, we're going to divide by the log of 3 on both sides. Okay, so x is going to be equal to the log of 30 divided by the log of 3. Alright, so log of 30 divided by the log of 3. And look at that, 3.095. That is pretty close to our approximate answer. So 3.09, and I'm going to round it to 6. I'm going to go to 3 decimal places. Okay, let's plug that in. Actually, if you want to plug this whole decimal in, I would recommend pressing store. Let's store the answer as x. Okay, and then that way we could do 3 raised to the x power. Remember, x represents this number now. We stored it, and we get 30. Okay, if we had rounded it, it would have been an approximate answer. Okay, moving on to the next one. Okay, as usual, when solving, we undo PEMDAS, so we got to add 4 on both sides. Undo adding and subtracting first. Okay, now once we get here, guess what? We're just like number 1. Just like number 1. Okay, so you go ahead and solve number 2 for x. If you have a calculator that does logs, I think on our computers, let me check here real quick. If we go to, if you have a computer at home, which most of you do, oops. Okay, and we go to accessories, and we go to calculator, and we change it to scientific. We can do log in here, I believe, looking for it. Here's the natural log. We could do, here it is, log. So we could do the log of 30. Invalid input. So you have to play around with it. I don't have time to play around with it right now, but there's a calculator on your computer that you can use to do logarithms. Okay? Alright. So number 3 basically is just like number 2. We have to undo adding and subtracting first. Alright. So let's bring that down. We get 5 to the x equals 7. Okay, follow the example, finish number 3. I'm going to be checking these answers here. Remember, 3 decimal places, round it to 3 decimal places. Okay, let's go ahead and do number 4. All right, undoing, adding, and subtracting first. Okay, now this we can cancel out with the 15, divide by 3, because we're multiplying here. So we're going to have 1/2 to the x power equals 5. Okay, I'll go ahead and finish this one. It's just like the previous ones we've been doing. We're going to take the log of both sides. So if I do the log of this side and I do the log of this side, then I bring that x down front. So I'll have x times the log of 1/2 equals the log of 5. Divide both sides by the log of 1/2. Okay, those cancel out, and let's see what we got here. We got the log 5. Hope you guys are having a great weekend, a great Easter, and I'm going to try to keep going here so we can get done, and we get negative 2.322. Negative 2.322. And again, you could plug that number in for x and see if this will give you 19. Okay, let's look at number 5. All right, notice we have a base raised to an exponent right off the bat. So we're going to take the log of both sides. Okay, we're going to bring that exponent down. Oopsie, forgot my log. Okay, and get this cursor out of the way. Now I'm solving for x, so what I think I will do is I'm going to do these two separately. You could do them at the same time, but just to not cause any confusion here, I'm going to divide both sides by the log of 2. Okay, so that's going to give me 4x equals, and I'm plugging this into my calculator over here. All right, 1.848. That's once I rounded it. Divide both sides by 4 to finish it off. And x is going to be approximately 0.462. And that's actually the big number that I got. So I'm going to go ahead and test this. I'm going to store this number in x. Okay, so that way when I press x and I press enter, that's what it represents. X represents that long number. So let's see what we got here. We got 2 raised to the 4 times, and we know what x is, and 3.6. Ta-da! All right, number 6. Okay, we have a base raised to an exponent, so there's nothing we can do except, what is it? I'm waiting. That's correct. Excellent. Take the log of both sides. That's how we can solve exponents. We can take the log of both sides. All right, so here we go. Here we go. Okay, next we're going to bring, now our exponent in this case is a group. So our group comes down front. I'm going to go ahead and put our group in parentheses, just so there's no confusion here. Okay, because if I hadn't, then we might be tempted to connect that 4 with the log and separate the x as separate, and it's not, it's this group times this log. Okay, so dividing both sides by the log to get rid of the log. Alright, so what do we get here? Log of 3 divided by the log of 19. Don't forget to press the log button. Alright, so there we go. So x plus 4 equals 0.3731143. Subtract 4 on both sides. So x is going to be, let's subtract the 4. We get negative 3.627 approximately. Okay, so that's one way of solving exponential equations, by using logs. Now, easier ones that we've done have looked like this. Easier ones, where the bases, we can make the bases the same. And 2 times 2 is 4, times 2 is 8, 2 to the third power. Remember this? This is how we started solving exponential equations, by making the bases the same and then setting the exponents equal to each other. So x is equal to 3. So 2 to the third power is 8. Perfect. So we have this method of solving exponentials, and now we have this method of solving exponentials. So I'm done. See you guys on Monday. We'll be doing more problems like this in class. Go Spurs, go.